This PowerPoint will take you through sections 3.3 and 3.4 in your algebra textbook. These sections deal with the question, when you have one equation with one variable, how do you solve that equation? Most often the one variable we'll use will be x, although we will use other variables just to remind ourselves that we can. So this section is essentially about solving for x. You should prepare to take notes as we work our way through this material. Please feel free to pause the presentation so that you can take notes as needed. First, we do need to remind ourselves of some vocabulary. There's an expression below, negative x plus 2x minus 8 plus x squared. The terms of this expression are the parts that are added together. This expression has four terms: negative x, positive 2x, negative 8, and positive x squared. A constant term is a term that has no variable part. It only has a number. In this expression, there's one constant term, and that is negative 8. Like terms are terms that have the same variable part in them. In this expression, we have two like terms, negative x and positive 2x. The variable in both cases is just simply x. Finally, a variable term is just a term that has a variable somewhere in it. This expression has three variable terms, negative x, x squared, and positive 2x. The value of these terms varies. It depends on what x is. When we're looking to solve multi-step equations, that is equations where it's going to take more than one step to get the x in the equation all by itself, we can do things that keep our equation balanced. So long as what we're doing keeps the equation balanced, we can solve for x using many different sequences of steps. Remember that if one of the things you're going to do is to multiply one side of an equation and then multiply the other side of the equation by the same thing, you have to multiply every term on both sides by whatever number you've chosen. And whatever you do to one side of the equation, you must do to the other, so you keep your equation balanced. If you're not sure where to start, which operation and what step to take first, I'm going to give you a sequence of steps that will always get you to the right answer. It may not always be the most efficient way to get to the right answer. There may be other ways to solve an equation that are shorter, but if you're stuck, the sequence of steps will always work. The first step is to apply the distributive property anywhere that it's needed. The second step is to combine the like terms on each side of the equation. The third step is to get the variable term by itself on one side of the equation. And don't worry, I'll go through an example with you to show you what each of these steps looks like. And the fourth step is to remove the coefficient on the variable term to get the variable all by itself. Finally, we'll want to take the answer that we get and plug it into our original equation to make sure that it does in fact work correctly. Let's see what these steps look like in an example problem. The equation we're going to work with is this: 2 times the quantity x plus 2 plus 3x plus 5 equals 14. Now, there's a lot of different first steps that we could take here. We could subtract 5 from both sides of the equation to begin with. We could apply the distributive property to begin with. What I'd like to do is to walk you through the 5 steps that I showed on the previous slide so you can see what they look like. So the first step was to apply the distributive property if needed. In this case, here's what it looks like. The original equation is shown on the top line, and we apply the distributive property. 2 times x gives us 2x, and 2 times 2 gives us 4. So we've applied the distributive property, and now we have the expression 2x plus 4 plus 3x plus 5 equals 14. The next step is to combine like terms. This is the equation that we had after we applied the distributive property. Now let's combine the like terms in it. In this case, we have two like variable terms, 2x and 3x. When we add those two together, 2x's plus 3 more x's is going to give us a total of 5x's. We also have two like constant terms, 4 and 5. When we add those together, we get positive 9. So this equation, when we combine like terms on the left-hand side, becomes 5x plus 9 equals 14. When you're combining like terms, there are some notes below about common mistakes. Remember that if you add 5x plus 3, you don't get 8x. 5x and 3 are unlike terms, and so you can't add them together. Also remember that if you add x squared and x, you don't get x cubed, because again, x squared and x are unlike terms. In one of them, the variable is simply x. In the other, that variable has been squared, and so we can't combine those, we can't add those together. The next step is to get the variable term by itself on one side of the equation. We had simplified our equation to look like this. 5x plus 9 equals 14. And I want to get the 5x term all by itself on one side of the equal sign. In order to do that, I'm going to need to subtract 9 from the left-hand side of the equation so that all that's left on the left-hand side is 5x. To keep my equation balanced, I have to subtract 9 from the right-hand side. When I do that, I still have 5x on the left-hand side. Negative 9 and positive 9 add up to 0, so there's nothing else to add on the left-hand side. And 14 minus 9 gives me 5 on the right-hand side. Now you don't need to write out the plus 0 like I've done here. I'm just doing that to show you why it is that we would subtract 9 from both sides of this equation. So now we have 5x equals 5. We have the variable term, the 5x, all by itself on one side of the equation. If you're not sure what to do to get the variable term all by itself, think about doing the order of operations, PEMDAS. Think about doing that in reverse, SADMEP. So look at your equation and ask yourself, is there any subtracting that I need to do to get the variable term by itself? And then do that. Then ask yourself, is there any addition I need to do to get the variable term by itself? And do that, etc. Next, we're going to get the variable by itself by removing the coefficient. Coefficient means the number in front of the x. In our equation, 5x equals 5, the coefficient is the number in front of the x. In this case, it's 5. We'd like to get rid of that 5 in front of 5x so that we can have x all by itself. Again, we're thinking about doing the order of operations in reverse. We've done all of the subtracting and adding we needed to do to get our variable by itself. Now we need to see if there's any division that we need to do to get the variable by itself. In this case, if we divide both sides of the equation by 5, what will happen is we'll get the x all by itself. 5x divided by 5 simply gives us x on the left-hand side. The 5 on the top and the 5 on the bottom cancel out because 5 over 5 is just 1. And so what we end up with is x equals 1. Notice on the right-hand side of the equation we had 5 over 5. That's a fraction that's equivalent to 1. Now we've gotten the x by itself, and we believe that this is the solution to our original equation, x equals 1. The very last step then is to plug this answer in to check to make sure that it works.